Hello students, in this class we will learn about matrices. Okay. So before learning matrices, we have to learn the definition of matrices. That means, what do you mean by matrices? Matrices is a plural form. In singular form, we can say matrix. So before learning matrix, we have to learn the actual definition of matrix. Okay. So what is matrix? Matrix means the representation of some numbers or algebraic expressions into some rows and columns. Okay. So matrix means the representation of some numbers or algebraic expressions into some rows and columns within a first bracket or a third bracket. Okay. And then we have to know what is the importance of matrix. The importance of matrix is, with the help of matrix we can represent, or with the help of matrices we can represent some simultaneous equation within a very easier and shorter way. And with the help of some applications of matrix we can also solve those equations. Okay. So now let us study about the definition of matrix. Definition. Matrix is an arrangement of some numbers or algebraic expressions into some rows and columns. That is horizontal arrangements are known as rows and vertical arrangements are known as columns. Okay. So the definition of matrix is an arrangement of some numbers or algebraic expressions into some rows and columns. That is, horizontal arrangements are known as rows and vertical arrangements are known as columns. Okay. So matrix is an arrangement. Okay. Like the arrangements of 2, 3, 6, 4, x squared minus 2x, 5, 0, x cube. So this is the arrangement of 2, 3, 6, 4, x square minus 2x, 5, 0 and x cube. Okay. So these arrangements represents a matrix where these are the horizontal arrangements known as rows, and these are the vertical arrangements known as columns. Okay, and within this third bracket, or with the help of this third bracket, we can represent these numbers by these horizontal and vertical ways. That is why this representation is an example of a matrix. Okay, now we will learn the general form of a matrix. So the general form of a matrix is, we represent this matrix by this alphabet A. So A represents this general form where Aij represents an element lies in ith row and jth column. This every arrangements, that means these every number or algebraic expressions are known as elements of a matrix. So elements of a matrix are the individual arrangements. So 2, 3, 6, 4, x square minus 2x, 5, 0, x cube, all are the elements. Okay. So in this matrix, individual representations are known as elements of this matrix. So in the general form, Aij represents an element lies in ith row and jth column. Okay. So A11 represents an element lies in first row and first column. Okay, so A11 is the element of first row and first column. A23 represents an element lies in 2 3 2 3 second row and third column. A Mn represents an element lies in mth row and nth column. Okay, so this is the general form of a matrix. So this matrix has, this is first row, second row, third row, continuing, this is mth row, this first number represents number of row. So this is mth row, this is the elements of third row, this is the element of second row, and this last number represents number of column. This is the elements of second column. This is the elements of third column. This is the elements of nth column. Okay, so in general we can say Aij. Aij represents an element which lies in ith row and jth column. Okay, so here matrix A contains m number of rows and in number of columns. Number of rows is m. This is first row, this is second row, this is third row, and continuing, this is mth row. That is why this matrix A contains m numbers of rows. Again, this is first column, this is second column, this is third column, continuing, this is nth column. Okay, that is why matrix A contains n numbers of columns. Number of elements in matrix A is m into n. Is Mn. Okay. So if a matrix contains m numbers of rows and n numbers of columns, then that matrix has m into n numbers of elements. Okay. Example. If matrix P contains 2, 3, 5, 6, x cube 0, 7, minus 2, 5x. So this matrix has 3 rows: first row, second row, third row, and 3 columns. This is first column, this is second column, this is third column. So number of elements of matrix P is 3 into 3, that is 9. 3 elements, 3 elements, 3 elements, that is why the total number of elements in matrix P is 9, that is the product of total number of rows and total number of columns. Okay. Again, total number of rows and total number of columns defines the order of a matrix. Again, total number of rows and total number of columns defines the order of a matrix. That is, matrix A has m numbers of rows and n numbers of columns. In matrix A, number of rows is m and number of columns is n. That is why we can write matrix A has m numbers of rows and n numbers of columns. So order of matrix A is m into n, which is read as m by n. Okay, so matrix A has m numbers of rows and n numbers of columns. That is why we can write order of matrix A is m into n, which is read as m by n. That means this matrix A has m numbers of rows and n numbers of columns. Okay. Depending upon the order of a matrix we can distinguish them. So depending upon the order of a matrix, we can distinguish a matrix. Okay. How? If a matrix has different number of rows and different number of rows with column, that is m not equals to n, then the matrix is known as a rectangular matrix. In these two examples, A matrix has two rows, number of rows equals to 2. This is first row, this is second row, and number of columns equals to 3. This is first column, second column, third column. So order of matrix A is 2 by 3. It is a rectangular matrix. Okay. Matrix A has 2 row and 3 column. That is why order of matrix A is 2 by 3. That is why we can say matrix A is a rectangular matrix. In matrix B, number of column, number of rows equals to first row, second row, third row, fourth row, 4, and number of columns, first column, second column, third column, 3. So order of matrix B is 4 by 3. So it is a rectangular matrix. Okay. So when number of rows and number of columns of a matrix are different, then that matrix is known as a rectangular matrix. If a matrix has equal number of rows with column, then that matrix is known as a square matrix. So when number of rows and number of columns of a matrix are equal, then that matrix is known as a square matrix. Example: 1 minus 3 7 x square 2x 5 0 x cube 4. So matrix P has 3 row and 3 column. So it is a square matrix. It has 3 row and 3 column. So its order is 3 by 3. Thus, we can say matrix P is a square matrix. Okay. So matrix P has 3 row and 3 column. So its order is 3 by 3. Thus, we can say matrix P is a square matrix. Okay. So when a matrix has equal number of rows and equal number of columns, then that matrix is known as a square matrix. Okay. Row matrix. If a matrix has only one row, then that matrix is known as a row matrix. Okay, if a matrix has only one row, then that matrix is known as a row matrix. Example: 7, 3, minus x, 5. So, the order of the matrix is 1 by 4, because this matrix has only one row and it has 4 columns. First column, second column, third column, fourth column. That is why order of this matrix is 1 by 4. Thus, matrix Q is a row matrix. Okay, so when a matrix has only one row, then that matrix is known as a row matrix. Okay. Similarly, column matrix. If a matrix has only one column, then that matrix is known as a column matrix. Okay, so when a matrix has only one column, then that matrix is known as a column matrix. If T represents a matrix 3x 4 5 minus 1, so number of rows is 4. First, second, third, fourth. But number of column is 1. So, order of matrix T is 4 by 1. Thus, matrix T is a column matrix. Okay, so when a matrix has only one column, then that matrix is known as a column matrix. null matrix. If all the elements of a matrix are 0, then that matrix is known as null matrix. Okay. So if all the elements of a matrix are 0, then that matrix is known as a null matrix. Example. So all the elements of matrix S are 0 and all the elements of matrix V are 0. So these are the examples of null matrices. Okay. Depending upon the order of a matrix, we can distinguish between matrices. Okay, so they are rectangular matrix when number of rows and number of columns are unequal, square matrix when number of rows and number of columns are equal, row matrix when a matrix has only one row, column matrix when a matrix has only one column, and null matrix when all the elements of a matrix are 0. Okay. Now we will learn what do you mean by diagonal element of a matrix. Diagonal element of a matrix element or elements of a matrix is or are that or those element or elements which has same number of row with column. Okay. So diagonal element or elements of a matrix is or are that or those element or elements which has same number of row with column. That means those elements which has same number of row and same number of column. That means we can say the element which lies in same number of row and same number of column, then that element is known as diagonal element. Example. 7, 3, 5. X square 8x 4, 0 minus 7 9x. Element 7 lies in first row and first column. So its number of row equal to number of column. Thus 7 is a diagonal element. Similarly, 8x lies in second row, second column. So its number of row equals to number of column. Thus 8x is a diagonal element. Nine x lies in third row and third column. So its number of row equals to number of column. Thus 9x is a diagonal element. Okay, so the elements of a matrix whose number of rows and number of columns are equal. That means those elements which lies in same number of row and same number of column, same number of row and same number of column, then those elements are known as diagonal elements. Okay, so here 7 lies in first row and first column, so 7 is a diagonal element. 8x lies in second row and second column, so 8x is a diagonal element. 9x lies in third row and third column, so 9x is a diagonal element. Okay, so diagonal matrix. A square matrix will be a diagonal matrix when all the non-diagonal elements are 0. Okay, so a square matrix will be a diagonal matrix when all the non-diagonal elements are 0. That is where Aij equals to 0 when I not equals to j. Okay, already we know Aij represents an element which lies in ith row and jth column. So when Aij equals to 0 follows I not equals to j, then that matrix is known as a diagonal matrix. Example. So here all the non-diagonal elements, these, 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 these are 0. That is why this matrix Z represents a diagonal matrix. Here all the non-diagonal elements are 0. So matrix Z is the example of a diagonal matrix. Okay. Now, if all the diagonal elements if all the diagonal elements of a diagonal matrix becomes equal, then that matrix is known as a scalar matrix. Now, if all the diagonal elements of a diagonal matrix becomes equal, then that matrix is known as a scalar matrix. Example. So this is a diagonal matrix, and in this diagonal matrix all the diagonal elements are equal. Here A11 equals to 3, A22 equals to 3, A33 is equals to 3. A11 means elements of first row and first column, that is 3. A22 means element of second row and second column, that is 3. A33 means element of third row and third column, that is also 3. That is why this matrix W represents a scalar matrix. When all the diagonal elements of a scalar matrix becomes 1, then that matrix is known as identity or unit matrix. Okay, so when all the diagonal elements of a scalar matrix becomes 1, then that matrix is known as identity or unit matrix. Generally, identity matrix is denoted by I n by n, where n represents n by n represents the order. Okay, so when all the diagonal elements of a scalar matrix becomes 1, then that matrix is known as identity or unit matrix. Generally, identity matrix is denoted by I n by n, where n by n represents the order of the matrix. Example: so these are the examples of identity matrices. Okay. Triangular matrix. Square matrix will be a triangular matrix if it is either upper triangular a square matrix will be a triangular matrix if it is either upper triangular, that is aij equals to 0 where I greater than j, or lower triangular matrix, that is aij equals to 0 where I lesser than j. A matrix will be a triangular matrix if it is upper triangular or lower triangular. So when a matrix will be when a square matrix will be a upper triangular matrix when all the when aij equals to 0 where I is greater than j. That means those elements whose row number is greater than column number represent 0, then that matrix is known as upper triangular matrix. Okay, when a square matrix has all the elements where again when a square matrix has elements whose column number greater than row number are 0, then that matrix is known as lower triangular matrix. Okay, example. In matrix W, A21 equals to 0, A31 equals to 0, A32 equals to 0. So matrix W is an upper triangular matrix. Okay. So here A12 equals to 0, A13 equals to 0, A23 equals to 0. So matrix E is a lower triangular matrix. Okay. So a matrix will be a triangular matrix when that matrix is either an upper triangular matrix or a lower triangular matrix. Okay. So for the upper triangular matrix, Aij will be equals to 0 where I greater than j. Here 2 1 is 0, A31 is 0, A32 is 0. A matrix will be a lower triangular matrix when Aij equals to 0, where I is lesser than j. A12 equals to 0, A13 equals to 0, A23 equals to 0. Okay. So a square matrix will be triangular when it is either an upper triangular matrix or a lower triangular matrix. Okay. So in this class we learned some definitions related with matrices. Okay. In our next class we will learn how in our next class we will learn how we can form a matrix depending upon some condition, and then some properties related with matrices like addition, subtraction, multiplication, etc. Okay.